In this video, I'll walk you through how to exploit the Stack buffer overflow vulnerability in EasyChat server. The content of this video will cover how to find Stack buffer overflow vulnerability of a multi-threaded server using IDA, then we'll look at how to craft the payload. I'll also show you how to develop a simple shell code as well. EasyChat server contains several built-in systems including HTTP web server, multi-threaded communications engine. The current version that they provide is EasyChat 3.1. The fun fact is, the current version of EasyChat is still vulnerable to SEH Stack buffer overflow attack, and this is the EasyChat version that we are going to exploit. We'll discuss what is SEH and what's a Stack buffer overflow later in this video. Now we know that the EasyChat server is a multi-threaded Windows server. Let's look at a simple multi-threaded Windows web server before jumping into EasyChat server. Multi-threaded server is similar to a single-threaded server, but additionally it allows to create more than one thread. Let's look at the binary code of the threaded server exe file with the help of IDA demo debugger. You will see something like this once you open the application using IDA. Apparently, we don't know whether there are any Stack buffer overflows available or not in this application. Before go through this disassembled code blindly, let's try to narrow down what places could be potentially vulnerable to buffer overflow attacks. Applications often get vulnerable to buffer overflows where user input sensitization has not implemented properly. So, our first step should be searching where this application accepts user inputs. Let's look at the echo handler function. In here you can see a function call echo incoming packets. Let's look at it. The reason to look at this is, this function would be the main function that could trigger the bugs through a malicious input. The receive function accepts 4 parameters: socket, buffer, length and flags. We can send 1024 bytes to the receive function. The user input is also limited to 1024. Let's explore the rest of the code. In here you can see another receive, and it allows to pass 2024 bytes to that same buffer of 1024 bytes. We have found a Stack buffer overflow vulnerability in this Windows server. What is a Stack buffer overflow? Stack is used to allocate short-term storage of a function. Once it's allocated, the stack frame has a fixed size. What we are going to do is, overloading this predefined amount of space in the buffer and point the instruction pointer to our payload to execute it instead of the intended instruction. Now let's look at how to exploit this vulnerability. Let's fire up this server and attach the service to the immunity debugger. Now we are going to craft a very simple shell script using Python. The purpose is to overflow the buffer and identify the memory address of EIP and point that to our payload. Let's implement this step by step. First, we need to instruct our script to connect to the server, then we need to send more than 1024 bytes to overflow the stack. Now let's execute this script to see what happens. See that the EIP has overwritten with 4 A's. We need to identify which byte get overwritten. from those 1200 bytes we have sent. Since we have sent 1200 A's, it's bit difficult to find the exact location. We gonna have to send a unique pattern and identify where it gets overwritten. To do that, let's generate a pattern using Metasploit Pattern Creator. You are of course free to write a script to do it or to use a different tool to generate this random pattern. Now let's add this pattern to our script. Then execute the script while the process is bind to the debugger. You can see that the EIP has overwritten with the 6A423969 pattern. Let's find the location of this pattern. It's at 1048 location. We can use this to create the blob and add it to the script. Once we run the updated script, we can see that the EIP has been overwritten with 4 Bs. Now it's time to find out the address that we should use to point out to our payload. We need to find a way to redirect execution to our malicious input. Go ahead and run this command. So now we have to search for a pointer that gives jump EDX. There are several pointers, but we can't use the modules that protected by ASLR. Before move on further, let's look what ASLR is. Address space layout randomization can be identified as a security measure used in operating systems. The main reason of using it is to protect against buffer overflow attacks. To perform buffer overflow attack, we need to identify the memory address we need to point to our payload. ASLR uses virtual memory management and randomize the locations of different parts of the program. Each time the program runs, the components get moved to different address in virtual memory. Now let's go back to the debugger. You can see that this application uses a module called libgcc, which is not protected by ASLR. Let's use these information we have gathered and update our script. Once we run the updated script, we can see that the EIP points to the address we have provided in the stack. Now let's try to add our payload to this blob. How we are going to create a payload? Let's see how we can create a simple payload. Let's create a shell code that opens the calculator on a Windows machine. When writing shell code for Windows, the memory addresses of functions that we intend to execute get different from Windows version to version. I'll explain how to create simple shell code to execute an exe on Windows XP. I will walk you through this. First, we jump to the shell code section, then we get directed to the shell return section. Then it copies the memory address of the string to EBX. Then it zero out the EAX. Unlike in Linux systems, Windows doesn't make system call. Instead it calls functions. Then I have moved the address of winexec of the target system to EBX. After that I have called the winexec function. Finally, I have cleared the registry again and loaded and called the exit process. Now we need to convert this to a shell code. I'll use a simple script for that. Not the shell code. I have selected an already sanitized payload from this website to use in this demo. Let's use this in our script and execute it to see what will happen. We have executed our payload. You can see that the calculator got popped up. We have gained the required knowledge. Now we can go ahead and exploit the stack buffer overflow vulnerability in EasyChat server. So, now we know the drill. Let's run the server and attach the process to debugger. You can go ahead and use IDA to identify the vulnerability. I have done bit of a background check of EasyChat server and found where the vulnerability is. We can use the username field to perform the buffer overflow attack. Let's send some junk characters using a script and see what would happen. Did get crashed, but the EIP did not get overwritten. It says to press Shift plus F7 to pass the exception to the program. Let's do that and run the program again. Okay. Now we can see that the EIP has got overwritten. There is an exception handler and we need to bypass it. When we look at the SEH chain, we can see that it has also got overwritten. Let's see at which location it has got overwritten. As we did previously, we can generate a pattern and send it. Once we do that, we can see that the location is 203. Now we need to identify a valid location on ESP where we can point our EIP to execute our payload. Let's try to find a module that has not been protected by ASLR. We can use Mona modules to load and identify the modules that used by this system. We can see that the SSLEAV2DLL is not using ASLR. Let's load this module and search for pop, ret functions. In stack manipulation, this is a one way of doing it. Press Ctrl plus S to start search sequence of commands. We got a memory address, but look at it carefully. If we use that memory address to create our blob, it will look something like this. We will create a null terminator if we use this memory address and our payload won't get executed. We have to find a proper memory address. Press Ctrl plus L to traverse through the matching results. Found it, we can use this memory address. Now let's craft our blob. At the end of the blob, we can place our payload. I have generated a payload and sanitized the bad characters. Now let's see this on action. You can see that the command prompt got executed on the targeted machine. When we look the current exploit available on ExploitDB, it has tested on Windows 7 Enterprise Service Pack 1. We did the attack on a Windows 8.1 machine using a Kali Linux machine as the attacker machine. If you are not familiar with socket programming, you can use these tutorials to learn about it. Now let's look what SEH chain is. Structured exception handler is used as security mechanism to mitigate buffer overflow attacks. In SEH, the exception handlers are linked to each other. This forms a linked list on the stack, and when an exception occurs, the OS select the best suitable handler to close the application. When an exception occurs, the OS passes the execution to address of an instruction sequence. In this demo, we have overridden the return address of the extended instruction pointer when exploiting the multi-threaded Windows server. In SEH overflow of the EasyChat server, we have overridden the stack after overwriting EIP, so we were able to overwrite the default exception handler as well. Now let's see how our SEH base exploit worked. Once we have sent 2000 A's, the debugger showed us that the exception got handled once we pass it to the program. As the next SEH pointer is before the SE handler, we can overwrite the next SEH. Since the shell code sits after the handler, we can trick the SE handler to execute pop. Pop read instruction, so the address to the next SEH will be placed in EIP, therefore executing the code in next SEH. The code will basically jump over some bytes and execute the shell code. So, I previously mentioned something called bad characters while developing the shell code. There are some ASCII characters which a program does not accept. So, we need to identify them before crafting our shell code. The way of doing that is passing all the ASCII characters and see what characters are not get reflected. Then we can exclude those characters from our shell code. One way is of do this is manually, by using the script. Let's see how to do it. We'll pass all the ASCII characters and try to identify the bad characters. Let's update the script. I have included this byte array in my blog. You can use it while doing this. Now run the server and attach the process to the debugger. Then run the script. Server did get crashed, but the values did not get passed. Let's go through the code again to see whether there are any mistakes we have done. I have removed the null character. Let's run the script now to see whether it works. Nope, why isn't it working? We are passing these values through a get parameter. Let's go to the ASCII chart and see what characters are we passing. Of course, we were passing spaces, tabs, which are not allowed to use in GET request. Let's try to remove them and run the script again. It worked. Now let's see ESP to see what characters got reflected. Now we have to go through this dump and identify the characters that are not available. I hope you have get an understanding of the process of identifying bad characters before crafting a shell code. If you had any difficulties in finding the location where the SEH chain get overwritten, no need to worry. I'll walk you through how to find it. First, generate a unique pattern. Now run the script. Now navigate to View, SEH Chain. Now right-click and select Show in Stack. Now let's find the location using this pattern. We have identified the location. Through this demo you have learned about how to find stack buffer overflow vulnerability on a multi-threaded Windows server. Then we have discussed about what ASLR is and how it is used. Then we have developed a shell code. After that we have discussed what SEH is and the SEH vulnerability of the EasyChat server. Then we crafted a payload and used a shell code to exploit the vulnerability. This assessment has been taken under the Offensive Hacking Tactical and Strategic module. Thank you for watching.